Welcome to another episode of Terry's Notes, and today we are going to be looking at the January 2016 paper number 9. Okay, so in this question here, we have a diagram. The diagram below shows the graph of 3 lines and a shaded region S defined by 3 inequalities associated with the lines. The inequality associated with the line y equals 3 is y is greater than 3. Right? So which line are we talking about? This is the line y is equal to 3. And we are saying y is greater than or equal to 3. So we are looking at the region that is above this line. Right? Now they said state 2 other inequalities which define the shaded region. So we have the line y is equal to 3, but if you notice, we also have the line x is equal to 2, and the shaded region lies to the right of this line. So this is the shaded region S here, and it's lying to the right of the line x is equal to 2, and is a solid line. So we have to say, so the first inequality is x is greater than or equal to 2. So that is one of the inequality. And the next inequality now if you look, this shaded region here is a triangle, and it's bounded by the line x equal to, y is equal to 3, and also x plus y is equal to 10. So we have x plus y. I won't put in the sign as yet because we need to put in the inequality. Now for this line, x plus y is equal to 10. The inequality can be x plus y is greater than or equal to 10, or less than or equal to 10. So how do we determine this? Now the line x plus y equal 10, the shaded region lies on this side. So if I were to take a test point, when I say a test point, I mean any point within the shaded region. So we have, let's say 4, 4, this point here, right? And we substitute it into the equation x plus y is equal to 10. 4 plus 4 is 10. But what can you say? 4 plus 4 is 8. So 8, you would realize, is less than 10. So therefore, that shaded region is really x plus y is less than or equal to 10. Right? Whenever we have an inequality and we want to determine which direction we are shading, we just use a test point. Right? If I choose a point that is above the line x plus y equal 10, let's say 6, 8. Right? Let's say this point here. If I plug it into this equation, 6 plus 8 is 14. 14 is not less than 10. So therefore, the inequality we want is x plus y is less than 10. Right? So this is the 2 inequalities we are looking for. Then the next question asks, the function p is equal to 5x plus 2y minus 3 satisfies the solution set represented by the closed triangular region. Identify 3 pairs of xy values for which p has a maximum or minimum. Right? Whenever we are dealing with linear programming, the points of interest, let's say we have a shaded region S. What we are looking at is the vertices. Right? So the 3 points that they are talking about, the first point will be, let's say this point here, this will be 2, 3. So the first point is 2, 3. The next point, if I read off this value here, it will be 7, 7, 3. So we have 7, 3. And the last point is this guy here, which is 2, 8. Right? So whenever we have to find a maximum or a minimum value, right, it's going to be one of those, the vertices of the if it's a triangle, if it's a square, right? So I just read off the coordinates of the vertices of the triangle, right? Now they said which pair of xy values make p a maximum. So what we're doing is, so we know what p is. P is 5x plus 2y minus 3. So what we're doing essentially is substituting. So for the first point, I'm going to say p is equal to 5 by 2, because x is 2 in the first instance, plus 2y, which is 3, minus 3. Right? Which will give me 5 2s are 10, plus 6, 16, minus 3, which is 13. Right? So that's the value of p when we choose the first coordinate. Now we need to find the value of p again using the second coordinate. So it'll be 5 by 7 plus 2 by 3 minus 3. 7 5s are 35, plus 3 2s are 6, minus 3. Right, and this will give me, that is 38. Is that correct? 6 minus 3 is 3. Right, so yeah, that's 38. And then p, so that was using the 0.73. Now we're going to use the 0.28. So it'll be 5 by 2 plus 2y, which is 8, minus 3. 5 2s are 10, 8 2s are 16, minus 3. 10 plus 16 is 26, and 26 minus 3 is 23. So the question asks, which pair of values makes p a maximum? So which one of these values of p is the largest? We notice that 38 is the largest value of p. So therefore, which point gives us that? The point that gives us that is 7, 3. Okay. Now the part B of the question is has to do with functions. So we have two functions defined. We have f of x is equal to 3 over 2x plus 1, and we have g of x equal x squared for each of the following. So we want g of a half. So g is really this guy here, and g of x is x squared. So if we have to find g of a half or minus a half, it will just be minus a half squared, which will simply give me a quarter. Right, now the second one, this is a little trickier. It's a compound function, so we need to find g of minus a half first, which we worked out and we got a quarter. So what we need to do is to take the quarter and plug it into the function f now. Right, so this is really equal to 3 over 2 by a quarter plus 1, right, which is equal to 3 over 2 multiplied by a quarter is a half plus 1. This will give me 3 over half plus 1 is 1.5, which is 3 over 2. Same as saying 3 over 1 divided by 3 over 2, which is equal to 3 over 1 multiplied by 2 over 3. 3's will cancel, and we end up with 2. Okay, so make sure you understand what we did here. So g of minus a half, we worked out that just by substituting minus a half into x squared. And then the second part asks for fg of minus a half. So we took the answer we got from the first part and we plugged it into the function f, and we got 2. Okay, and the last part, find an expression for the inverse function. Right, so let me just write back what f was. F is 3 over 2x plus 1. So the function is 3 over 2x plus 1. How did I write it? Okay, f, okay. Okay, so they wrote it as this. Right? Now, in order to find the inverse of this function, the first thing we need to do is let y equal to 3 over 2x plus 1. Now, the next step here is to interchange x and y. So we interchange x and y. So anywhere we see y, we put x, and anywhere we see x, we put y. So this becomes x is equal to 3 over 2y plus 1. And the next step is to make y the subject of the formula. Right? X is the same as x over 1. So what we do, we cross multiply. So we end up with x, open brackets, 2y plus 1 is equal to 3. So 2xy plus x is equal to 3. Is that correct? Yes. Right. So 2xy is equal to 3 minus x. Let's move across here. So we want to make y the subject. So y is equal to 3 minus x all over 2x. Therefore, the inverse function f is equal to 3 minus x all over 2x. So make sure you understand the steps. Once you have to find the inverse of a function, the first thing we do, we let y equal to the function. Then we interchange x and y. What that means is that anywhere we see y, we put x, and anywhere we see x, we put y. And the next step is to make y the subject of the formula. So once we made y the subject of the formula, that is simply what the inverse is. Okay?